Hello and welcome to this screencast. My name is Chris Dillard and we're going to walk through the concepts of parameters and arguments and object-oriented programming in Raptor. And this comes back to the idea of something called encapsulation. And so we're going to take a look at that as well. In this lesson we're going to cover the idea of encapsulation, the idea of local variables versus fields, setting up methods to expect data, passing data into said methods and classes. So the first thing we're going to look at is encapsulation. Encapsulation, according to Wikipedia, is the packing of data and functions into a single component. The features of encapsulations are supported using classes in most object-oriented programming languages, although other alternatives also exist. It allows selective hiding of properties and methods in an object by building an impenetrable wall to protect the code from accidental corruption. Some programming languages, blah 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 blah. You can go ahead and pause if you want to read the rest of this. But encapsulation is one of the primary ideas behind object-oriented programming. It's the idea that basically encapsulation is protecting data from the unintended corruption from outside sources to make sure that the data inside is reliable. Data inside of the fields that exist inside of instances should only be directly manipulated by the instance itself. Now there are some exceptions to this rule, but this is generally the idea. If data needs to be changed, methods should be used to tell the instance to do it itself. So you're telling the instance, hey, this needs to change. This number that you have, this data that you have, you need to alter it in some way. You shouldn't do it from the outside of the instance. If data needs to be sent into these methods, it should be done using the paradigm of parameters and arguments, which we'll look at in a moment. If you want to think about what this means in a real-world sense, the analogy I make is, let's say you're a person and you walk up to a cashier at a restaurant or at a store of some sort, and she tells you that you need to pay, or he tells you, whichever the case may be, that you need to pay $20 to buy the item that you walk up with. So she is asking you to change something about yourself. She's asking you to change the amount of money that you currently have credited to you to deduct $20 from you. So you pull the money out of your pocket and hand it to her. So she has asked you for this data or this number, and you oblige by taking it out of your purse or wallet and hand it over to the cashier for services rendered. Without the idea of encapsulation, this is to say that the cashier could just reach over into your pocket, grab the money from you, no problem. Okay, so that's the idea behind this, if you want to think of it as an analogy. This does take a little bit of extra work compared to just, going willy-nilly into it, but it is one of the primary premises of object-oriented programming, and we must follow it. Alright, so if we want to look at this inside of Raptor, I've prepared a class called Calculator, and we'll open up this Calculator class and take a look at what it does. The calculator has two fields, both of type integer. Both are public, which means that anything can actually see and alter these fields. This breaks the rule of encapsulation. We'll fix that in a moment. It has one constructor, obviously, and it has one method called add numbers. Right now, add numbers doesn't do much. Alright, so if we can close this and go look at the behavior of this class. Alright, so we see we have these two fields. The constructor does nothing. The add numbers function does nothing. So let's say that we want the add numbers method to actually do something. So we'll call this demo calculator. Alright, whenever this method is called, it will simply output to the console the sum is. Actually, I'm not going to do that because we haven't gotten to concatenation yet, so I'll just do number this dot number field 1 plus this dot number field 2. So what this will do is it will take these two fields, the data that's inside of these fields, add them together, and output it to the console. That's all it will do. Okay. So let's say that we're going to actually do this inside of the main. So let's say, for example, we're going to, first thing we do is we're going to instantiate a calculator. We'll just call it calc1. It's a new calculator. Alright. So the first thing that will happen is it will run its constructor and do absolutely nothing. But let's say that we actually want to change some of these numbers, so we'll change some numbers inside. Let's set this, calc1 dot, was it number field? Number field 1 to 5. Let me make sure I have that right before I go any further. Number field 1, okay. So calc1's number field 1, we'll set it to 5. And calc1's number field 2, we'll set it to 10. And then we'll call that method. Calc1 add numbers. So if we step through this program, first thing that happens is an instance down here on the heap will be created of calculator class that is giving a memory ID. We can see that when it's instantiated, no fields are initialized. They're just declared. So next thing that happens, we access this instance called calc1 and we'll set its number field 1 to 5. Alright. The number field 2 we'll set to 10. Then we'll call this method called add numbers, and what add numbers does, it outputs whatever is in this field added to whatever is in this field, and it takes it and outputs it to the console. And if we look at the console, we can see that this is what it does. Okay? But the idea behind encapsulation is we should not do this. We should not, calling the method is fine, but we shouldn't be able to access the field in a way that we can actually change the data. Alright, what if you have multiple things going on in a program at once, and they both access that instance and try to jumble the numbers in the same way at the same time? You're going to end up with inconsistencies. You're going to end up with data that's not reliable. And that's what encapsulation attempts to prevent. Now, Raptor will let you do this. It will let you go in and change these fields, but if you're using an actual programming language, it will not allow this, even from your main function. Alright, so you can change it to private, or sorry, you can leave it at public if you want to, and be able to access it from anywhere, but that doesn't follow the ideas behind encapsulation. So in class, you're going to leave all of these as private. Okay. Fields that are not private will not be accepted anymore. But methods you can leave as public. Alright, so the idea behind this is that we can go into an instance of calculator. Now we can do a couple different things, like instead of sending this data inside like this, get rid of that, we could just collect it inside of add numbers if that's what you want to do. We could say for the first input, what number do you want to add? And say this dot number field 1. Same thing for the next one. What do you want to add to the previous number? Say this dot number 2. Now this is not breaking encapsulation. You're actually having the function that exists inside of the instance to alter the fields of the instance. That's okay. You can do that. But what if you actually want to send the information inside of here? You don't want to actually collect this information this way. Alright, so this is where local variables come in. Now, local variables are variables that, for example, we can say input here, and we say enter a number. Now, when we run this, it says enter a number, we say 23, and you'll see here that that number is stored locally. It only exists in the context of this function. It doesn't change anything about the fields, and as soon as the function is exited, that local variable gets destroyed. So the way to think of local variables is they're temporary storage. Alright, once the instance is actually left, those don't exist any longer. Fields are permanent storage. Whenever you want to store information permanently, or to actually have it to be retained in some way, that's what the fields are for. Alright? So, using that kind of logic, we can say, for example, what if we want to collect some variables inside of main, and we want to give the add numbers method call this information? Well, encapsulation says that we can't do something like this. We can't say enter a number to add, and we say, okay, for example, number 1. In this way, Raptor does adhere to the principles of encapsulation. And what number do you want to add to it? The sound you hear in the background is the air conditioner. It's old and noisy, kind of like me. Okay, we say, for example, number 2. Alright, so these will collect 2 local variables. Go ahead and run this. We make the calculator, enter a number to add, 34, another add 23, number, and now we say, okay, we have 2 local variables. Goes into the add numbers method call, asks for more numbers, 44. Alright, so we understand that these local variables exist inside of main, number 1 and number 2. But let's say we're inside of calculator, but we want to actually access these variables that we created. Now we can't just go in here and say, I want to take whatever number 1 is. Let's make another one called x, and it's going to be set to number 1. That doesn't work. Well, where's the autocomplete? We'll add that to number 2. The reason number's coming up is because I have it right here. It doesn't see those. Okay, this instance can't look out and see this information. It can't see number 1. It can't see number 2. But what we can do is set up a parameter which is telling this method that we're going to send some information to it. Whenever we call this method, we're going to send information into it. Okay? So this is how we do that. And we're going to ignore these fields for now. We'll come back to those in a second. Alright, so inside of the UML, we'll go inside of the class. Now, this is going to be using a part of the members dialog box that we haven't used before, and that's the syntax part. So inside of the syntax, we're going to tell it this add numbers function that we're going to send some information. Now, just like these fields that we created, that needs to know the type of data it is. We can have it be an int, a float, a string, whatever. The same thing is true for parameters. So let's say for add numbers, we're going to send one number inside. We're going to say, we're going to send an integer to you, and we'll call it x. Now, what this has done is it says, okay, whenever I call the add numbers function, it's going to be expecting one number, an integer. The number that we send is going to be known inside of here. It's going to be similar to a local variable that only exists here by the name of x. Alright, so we've set up a little box here, a little box that's going to get some data. It has an x on it as far as this method is concerned. Alright, so we can output, for example, x plus 5. Alright, so whatever number we send, it's going to output that number plus 5. Okay, so what we can do here is we can say enter a number to add, and whatever number that we use, we can call that add numbers function and send that number. Whoa, too big. Alright, so here we get a local variable called number 1, whatever the person enters, and we send that variable or the data to the add numbers function. Now, to make it more simplified, let's do this first. We'll just get rid of that, and we're going to call add numbers, and we're going to send 10. Alright, so add numbers 10. Alright, so we call this method, we say, okay, instantiate a calculator, and then we're going to call the add numbers function, which is expecting an integer. Okay, so call that function. X is equal to 10, so we send 10 into the spot. It's going to output whatever x is, which is 10, plus 5. And you can see it has done so. Alright. Now, we don't have to just send in hard-coded values. We can make this dynamic, like I was showing before. Let's say inside of main, we actually collect, enter a number to add to 5. And we call this number 1. And instead of sending a static value of 10, we're going to send whatever the user enters into this local variable. So we'll say number 1. Alright, so this time when we run it, enter a number, and let's say this time we say 20, or 209, that's fine too. Alright, so number 1 is equal to 209, so now it calls the add numbers function on the calc1 instance, sending it the value of number 1, which right now is 209, because that's what we entered here. Alright, so goes inside of here, and it says 209. 209 plus 5. Output that. Alright, so it outputs 214. Okay? So that's the idea of parameters. Now, the difference between parameters and arguments, this Windows screen's coming up. Sometimes this virtual machine gets a little bit slow, especially with Windows 10. The variable that you set up to actually be received inside of the method, so this x little variable, local variable that you make, is referred to as a parameter. The data that you send that actually goes into that variable is an argument. Alright, now the terminology is important in a way. So just understand that when you're calling the method and then giving it some data, this data is an argument. Once the method is running and you're telling it here that this is a variable that the data is going into, the variable itself is a parameter. Okay, so x is a parameter. Here, number 1 is an argument. Only here. Here it's a variable, a local variable. But here it's an argument. Alright? Alright, so we can also send more than one argument. We can make more than one parameter here. So let's say, for example, in the add numbers method, we're not just going to send one integer, we're going to send 2. The first one will be x, the second one will be y. We separate the different parameters with a comma. Okay. Now, if we run this now, this is going to be an error you might get a lot. Go ahead and run it, make a new calculator, enter some data, and we say 45. Now, it's going to give me an error right now. Can't find a method add numbers with one parameter in the class calculator. So what that's telling me is, yes, you have an add numbers method, but the way it's set up is not to receive only one parameter, which is all I'm giving it, because I just changed it to actually be expecting two parameters. It's expecting an integer x and an integer y. But when I'm calling the method here, I'm just providing one argument. So that's what that error means whenever you see it. So what number do you want to add? And here we'll say number 2. Alright, so whenever we call add numbers here, we can send the value of number 1 and number 2. Alright, so now we run it. First number is that. Don't want to do that. Alright, so now we have in number 1, the value is this number, and number 2, it's this number. Method gets called. X is equal to what was in number 1. Y gets the data that was in number 2. Send here, send here. We're going to output whatever x is, this one, plus 5. Now we can also take advantage of y if we want to. You would just output, for example, x plus y. Makes sense. Okay. What if we want to send this data inside to the field? Whatever's inside of x, we want it to go inside of number 1, or number field 1. Whatever data is in y, we want it to go into number field 2. For example, when this data is sent in, let's say, for example, add numbers is always going to add the fields. It's always going to grab the field number field 1, and the number field 2. Alright, so right now it's always going to be 0. So let's say we want to send in some information here in the x parameter. The information in the x parameter will then be stored permanently inside of the number field 1 field. The information that's inside of the y parameter will be stored permanently into the number field 2 field. Alright, so we're going to set, so remember set is what we're trying to change, this dot number 1 equal to x. X is the parameter. Alright, so whatever gets sent in to x, we're going to set the number field 1 field equal to that. Same thing, we'll say this dot number field 2 is equal to y. So remember that these parameters function as local variables, more or less, in this instance. So we can run this, get a number, big number, get another number, sounds good. Now we have number 1, local variable, equal to the first number that I entered, local variable number 2 equal to the second one that I entered. We're sending that information in this spot, number 1 over to x, number 2 over here. Now when you look at this, remember that don't concentrate on the numbers or the variable names or whatever that's inside of here. What's important is their position in relation to the comma. Before the comma is one box. After the comma is another box. That's what this reads. Okay, this is the box that's before the comma. This is the box after the comma. Okay, the names aren't that important. What's really important here is whatever data is before the first comma and whatever data is before the second comma. Okay? Alright. So we're sending this data over to the first box over here, which just happens to be called X. As far as this method is concerned, this is X. Alright? So we go over here and we say that X is now equal to the data that was sent in that position, and the first position, the first argument, or the first parameter. The second parameter, called Y, as far as this method is concerned, is set equal to the data that was sent. Alright? But the fields were declared but not initialized to any value other than 0. So now we can say, okay, this number field, we're going to set it equal to X. Alright, this dot number field 2, we're going to take the data that's inside of Y and put it in this field. Now we're going to output this dot number field 1, so this plus this dot number field 2, which is this, to the console. And there you go. Now, the methods that we're using here, or the techniques, I should say, this doesn't really have any advantage over the previous way, but or as far as just using local variables. But if you're going to follow, or if you need to follow the paradigm part of encapsulation, you need to know how to actually pass arguments into parameters. You need to pass information to methods. This is how you do it. Now, when you're going to be making multiple instances of a class or use multiple classes, you need to know how to do this. Okay, because especially in other programming languages, it won't be allowed for you to actually be able to just go over and access a private field of another instance. It won't let you write it. It won't let you read it. You can set up properties to actually let you read but not write it, or write it but not read it, or anything like that. But that's beyond the scope of this video. Alright, so inside of Raptor, that is how you set up your parameters. Again, you go inside, you grab your method, and you, inside of the syntax section, set up the type of information that's going to be passed in the first position, and then give it a name. So we're going to create a variable called X in the first parameter position, which means that's before the comma. The second parameter position is going to be called Y. As far as this method is concerned, it will be called Y. It will be of type integer as well. Okay. Alright, so that concludes this lesson on parameters and arguments. We'll be implementing this inside of the Computers and Technology classroom next time we have class. If you came here from a different source, you're not actually in my class, I hope you learned something as far as Raptor goes, Raptor in object-oriented mode. And well, I guess that about sums it up. Have a great day.